welcome to this video where we are given 3 points A, B and P, and we are supposed to show that the lines AP equal to the length BP, and the red box on top is just a reminder for us that we actually have this formula to find the length of the line segment, which is given here in this box here. Alright, so I am going to make use of this particular formula here for our question. So the very first thing is I want to know what is my length AP. So it involves the point A, which is -2 and 1, and my point P, 3 and -4. Okay, so in this case I'm going to just label this as my x1 y1 and my x2 y2, so that when I apply this formula out, AP will be equals to the square root of x2 minus x1, so I will have my 3 minus my -2, the whole thing bracket square, plus y2, which is -4, good to put a bracket, minus away my 1. Oh yeah, actually it's good to put bracket every time you substitute a value in, and key into your calculator, but take note of what Mr. Tan is going to do next. Mr. Tan is only, I repeat, only going to find out what is the value or the number inside the square root, and that should give me a value of 50. Okay, because this is not about finding the length of AP, rather it is about showing that the length of AP equals to the length of BP. This form here in the root form is actually if it does not give us an exact value, this form is actually one of the most accurate value. Okay, so the next thing here for Mr. Tan would then be to repeat the whole process again. However, this time round is BP. So Mr. Tan, being a very careful person, will write this down so that I know, and I'm going to repeat. So I'm going to make this be my x1 y1, x2 y2, so that when I find BP, again I would have my x2, 3 minus 4 x1 bracket square plus my -4 minus my +3, the whole thing bracket square, and again do take note, Mr. Tan is going to simply find the value of the value or the number inside the square root, and I would get 50. Having shown that AP equals to square root 50 and BP equals to square root 50, we are crystal clear that therefore the final answer, do write it down as well, that therefore AP does equals to BP shown. And through this video, I have shown you how to apply the formula to find the length of a line segment when given the coordinates of the 2 points. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given the vertices of this triangle ABC for all the vertices, point A, point B and point C. And our job is to now show that this triangle is an isosceles triangle. And it is important to note that for an isosceles triangle, there are some properties that we could actually exploit. One of it would have to be that there are two sides that are equal. Meaning that for this particular question, all we have to do is actually to make use of this formula to find all the three lengths of this triangle, and if there are two sides that are equal, we have successfully proven and shown that triangle ABC is an isosceles triangle. Okay, so without further ado, I shall start by finding the length of AB. And this is a habit of Mr. Tan. I like to write my coordinates for all the points that I'm trying to find, because then I would always remind myself to do this, so that when I try to find the length, I will not make careless mistake. This is the square root of x2 minus x1, so this one will be y2, x2 will be 1 minus negative 1 bracket square plus 8 minus negative 2 bracket square, and this will give me a value of, again, as the square root of, I just need to find the value inside the square root if the answer is not an exact value, and in this case it is indeed not an exact value. And because we don't know, we are given the coordinates, this one is actually in terms of units. As we continue to work on two more lengths before we can safely conclude. Yeah, so the next length I'm going to do will be point B and my point C. My point C would be negative 5, 4, so that again I know this is my x1, y1, x2, y2, so my length BC will be equals to the square root of negative 5 minus 1 square plus 4 minus 8 bracket square. And let's see what will this give me. This will give me a square root of this value. I just need to press my calculator, and that will give me a value of 52. Okay, so now we know A, B and BC are not equal, and therefore the last line that we are going to find would be AC. So this one I'm going to write it at the top. So my point A is negative 1, negative 2, and my point C is negative 5 and 4. So I'm going to replicate for the third time. So I'm going to go a little bit faster here since it is the same approach. Minus -1 square plus 4 minus my -2 square. And for this, when I press my calculator, for this particular value, it does give me a value of square root 52 units. And since we have successfully found out that through our working, AC is equals to BC, therefore we have successfully proven and shown that triangle ABC is an isosceles triangle. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given 2 points, P and Q, and we are given the distance, which also is another word for length. So I repeat, distance is the same thing as length. Okay, and therefore we are able to make use of this formula to help us in our solving of this problem now. Alright, since we are given the length 5 units, we are also given the 2 points. So again, I'm going to write it down, the 2 points at the side. This will help us later, or help Mr. Tan here to be really clear that I just need to get point P to be x1, y1, Q to be x2, y2. So therefore, when I apply the formula, I will be very clear. Okay, so PQ, then given the length, I know PQ equals to 5, right? But PQ at the same time is also equals to the, if I apply the formula to find length PQ, it will be 1 minus -3 bracket square my x1 minus my x2 minus x1 plus my y2 minus y1, in this case is k minus 2 bracket square, and this happens to be 5. Alright, so the next step would then be for me to continue to simplify it. This is 1 minus -3. This will be 4 square plus k minus 2 is still k minus 2 bracket square. The square root equals to 5. And now, to make sure that I do not have the square root, I'm going to square both sides, meaning the next step you will see would be, first of all, 4 square is 16. K minus 2 bracket square, I'm not going to expand first. And because I do not want the square root, the next step you will see is that I square both sides. So I will have a 5 square here. Okay. And after which, then I will be able to continue to solve for this fairly quickly. So 16 plus k minus 2 bracket square is equals to 5 square is 25. So I'm going to minus 16 on both sides, such that there's no more 16 on my left hand side of this equation. (25 minus 16 is 9). And so, take note of my next step. My next step would be interesting because if I do not want the square, I will have to do something like this. I will have to square root both sides. When I do that, then my k minus 2 therefore will be equals to either a positive square root 9 or a negative square root 9. And square root 9 is 3. So final answer, I will have 3 plus 2 here because I add 2 on both sides. This will be 5. Or my k minus 2 is equals to negative 3. K will be therefore equals to negative 3 plus 2 when I add 2 on both sides. K equals to negative 1. So these are the two possible answers for K. Notice how Mr. Tan approached this question. Mr. Tan first checked to see what information do we have, and Mr. Tan saw that they give us the distance, which is the length, and the coordinates of the 2 points with one of the coordinate a variable or unknown that we are supposed to find. So Mr. Tan applied the formula for the length of a line segment and just solve this particular equation that was formed after I applied the formula. With that, we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given 2 points, point A and point B, and we are supposed to find the coordinates of point C such that AC equals to BC, and there is a very important information here. Point C is on the x-axis. What does this mean? This means that on the x-axis, which I'm going to just draw on here, where is the x-axis? X-axis is here. Okay. And if I were to just draw quickly the y-axis, point C lies on the x-axis, and any point on the x-axis, the y coordinate is equal to 0. This is a very important clue. This means that we could, for a start, let P0 be the coordinates of point C. Okay. Once we have established this, then we could apply what we have by using this information now. AC equals to BC. That means I will have to make use of the formula that we are seeing at the top. So for point A and C, For convenience sake, I'm going to just write it down here. A is 3, 4. C is P0, so that I could have my x1, y1, x2, y2, and when I substitute into the formula, I will get my AC. Same goes for B and C, point B and point C for the length BC. So that will be what you are going to see here, where I have my P minus 3 square plus 0 minus 4, all positive value, so I did not put a bracket. So on the other end, my point B is negative 3, 2. Again, I have my C. So if I were to apply the formula again, then this is what you will see. Again, I will have P minus, this is a negative value, so I put a bracket, plus 0 minus 2. And we just have to solve this equation here. Okay? So I'm going to just square both sides. And once I square both sides, you would then see that the square root is gone. I only left with P minus 3 bracket square plus 0 minus 4 bracket square is 16. I will have P plus 3 bracket square plus 0 minus 2 bracket square is 4. This point I would expand and simplify the brackets. So this one will give me P square minus 2 times P times 3 plus 3 square. If I make use of the special algebraic product, I apply the same algebraic product for this, I would have P square plus 2 times P times 3 plus 3 square. I have my plus 4 there. So as I continue to simplify, I would slowly but surely get closer and closer to my final answer. Yeah, so I will have P square plus 6, it should be minus 6P plus 9 plus 16 equals to P square plus 6P plus 9 plus 4. Continue to simplify them. Alright, 25 equals to P square plus 6P plus 13. And I'm going to minus P square on both sides, so that you will have this. I would also going to minus 6P on both sides and minus 13 on both sides, and let's see what we have. Okay, so the next thing would be P square minus P square 0, negative 6P minus 6P, that will give me negative 12P. 25 minus 13, that will give me a positive 12 equals to 0, and I'm continue to solve for it. I will have negative 12P equals to, going to minus 12 on both sides, So that will give me going to minus 12, so that I will have negative 12 here. And finally, the final answer for P would involve me dividing by negative 12 on both sides, so that I will get the value of P equals to 1, and therefore the coordinates of C for this particular question, C will be 1, 0. With that, we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given 2 points A and B, and we are supposed to find the coordinates of point C that is on the y-axis. This is a very important information because this tells us that given a y-axis, which I'm going to just illustrate here very quickly. This is my y-axis, and my x-value, x-axis, going to just put on the x-axis. So any point on the y-axis, you must be able to see that the x coordinate is in fact 0. Okay, so that is something that is very important, which we would have to write it down. We are going to let the point we already know is 0 for x coordinate, but we do not know the y coordinates of this point C. So I'm going to let a letter or variable to denote this, h. For example, will be the coordinates of point C. Okay, next thing is, the next piece of information that they give us is that there's an equidistance of this point C from point A and B. This means that AC and BC, they are the same. Point C C to A and C to B, the length is the same, equidistance. And with that in mind, right, I would then be able to apply this formula to find the length of AC and BC and to equate a equation to help us solve for H. Okay, so that is the approach. So my A, -4 and 5, and my C, 0 and H. This is what I usually like to do. So once I have decided which points are my x1, y1 and which point is my x2, y2, I would then apply the formula. And that's where you will see me writing this down. 0 minus -4 bracket square plus h minus 5 bracket square. That is for my AC. For my BC, again, I would like to just make sure that I don't make careless mistake. And this will be my x1, y1, this will be my x2, y2, and that's where I'm going to apply the formula again. So I will have my 0 minus 7, oops, bracket square plus my h minus 2 bracket square, and I'm going to square both sides such that my next line, there will no longer be a square root, and this bracket square will be equals to 16. Okay, so this will be 16. I'm going to expand and simplify this to give me h square minus 2 times h times 5 plus 5 square equal, again replicating, this will give me a value of 49, and this will give me, after I expand and simplify using the special algebraic product, h square plus, should be minus 2 times h times 2 plus 2 square. Let's continue to expand and simplify, alright? So I would have h square minus 10h 16 plus 5 square would be 41, and this will be equal to h square minus 4h, and on the other side of the equation, 49 plus 2 square will be equals to 53. And at this point here, then I will start to simplify further. I am going to minus h square on both sides, so there is no longer h square. I'm going to add 4h on both sides, so that my right hand side there's no more h terms. I am also going to minus 41 on both sides, and once I've done all those steps, then this will be the next line. I'm left with negative 10h plus 4h, that will give me negative 6h. 41 minus 41 is 0, so the other side I'm also left with 53 minus 41, that will be 12. So I'm going to divide by negative 6 on both sides, so that I will be able to get what is the value of my h, and that will be negative 2. Therefore, we have successfully find the coordinates of C. 0, negative 2. So as you can see from this particular example, the very important piece of information that you do need to know is that from this line, point C is on the y-axis, we are able to get the x coordinate of the point C. This is really important because we would then only need to find the y coordinate of this point C. And we could do that from the next piece of information, where they told us that point C is equidistant from points A and C. So that is where I apply the formula for the length of the line segment. Thereafter, I have successfully formed an equation. I solve for the unknown. And if you do like this video, do give it a thumbs up, and thank you for watching. Have a nice day. Hello everyone, welcome to this video where we are given 3 points P, Q and R, where points P and Q, the coordinates are given in numbers, and for points R is in A and B. But one very important clue is here. R is on this line x equals to 3. This is very important. This means that the x coordinate of R, which is A, is in fact 3. Okay? So this clue tells us that A equals to 3. And with that, we could then apply the formula on top here to find the coordinates of R, which is the missing B down there. Okay, using this next piece of information, PR equals to QR. Alright, so without further ado, usually I do like to write this down. If it's PR, that means my P is 1. 6.5, my R in this case, I already know my A is 3, and B we don't know. So this will be my x1, y1, x2, y2, and then I would be able to form the equation now, where PR is equal to QR. Yeah. So this is what we are going to do next. I'm going to then have this. So x2 minus x1, meaning 3 minus 1 bracket square plus my b minus 6.5 bracket square. This one will be equals to my QR. So for my Q and R, right, I'm going to replicate here. Q would be 2,5. Again, my R, 3 and B. So in this case, x1, y1, x2, y2. So on the other side of the equation, you would see 3 minus 2 bracket square plus b minus 5 bracket square. So now my next job would then be to simplify this. I saw that both have square root, meaning I'm going to square both sides. So the next line, you will not see any square root anymore. Rather, you will see this as 3 minus 1 bracket square will be 4. And I'm going to continue to expand and simplify this using my algebraic product. Okay, so I will have b square minus 2 times b times 6.5 plus 6.5 square equals to, I will replicate for the other side here, 3 minus 2 bracket square equals to 1. Again, this part here will also make use of the algebraic formula. So I will have my b square minus 2 times b times 5 plus 5 square. So I'm going to simplify. I will have b square minus 2 times b times 6.5 is 13. B 4 plus 6.5 square would give me a value of 46.25. So on the other side of the equation, I will have b square minus 2 times b times 5 is minus 10b. And again, 1 plus 5 square will give me positive 26. So let's continue to solve for B. And once we have B, we will be able to get the coordinates of R. So on the next line, I would then minus B square on both sides. I would add 10B on both sides, so that my right hand side there is no more B. I would minus 46.25 on both sides, so that my left hand side there is no more number. And the next line you would then see is negative 3B is equal to negative 20.25. So I would then divide by negative 3 on both sides to get my final answer for B. B will be equal to 6.75. And therefore, the coordinates of R, A is 3, B is 6.75. So from this particular question, do take note of how Mr. Tan approached this question. Mr. Tan tried to look from the information given, like R is on the line x equals to 3. That gives me the value of A. And because the next piece of information is PR equals to QR, this has something to do with the length. I built on my knowledge of using the formula of the line segment to form an equation and solve for the next unknown B. Okay? With that, we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching. Have a nice day. Hello everyone, welcome to this video where we are given point A, 1, -8, and oh, this is a really important piece of information. Point B is on the x-axis. This tells me that the x coordinate of B, we are not too sure, but we do know that since it lies on the x-axis, and any point on the x-axis, the y coordinate is 0. Okay? So the very first thing is we are going to let h be the x coordinate of B. And that will allow us to find for part A, because we are also given another piece of information, which is the gradient of AB is -2. So from here, gradient, I would then need to remember gradient M is equals to y2 minus y1 over x2 minus x1. Okay, so for part A, with these pieces of information, we are able to solve for coordinates of B. We are going to let B, H0 be the coordinates of B. And with the gradient of AB as -2, I would then be able to have the x1, y1. I'm going to just write at the side here, okay? My point A is 1, -8. My point B, now we are going to let H be the x coordinate, so that I will have my x1, y1, x2, y2, and the gradient then, given this, would be 0 minus my -8, H minus my 1. and we know that this is equals to negative 2. Okay, so let's continue to solve. So from here I will have 0 minus negative 8. This will give me a value of 8. H minus 1, I'm going to multiply on both sides such that I will have negative 2 times h minus 1. Continue to solve. I have my 8 equals to negative 2h, positive 2 here, and thereafter eventually I will get my value of h. Pretty soon I'm going to add 2h on both sides and minus 8 on both sides. So slowly but surely, let me just create some space here. As I shift this a bit and make it bigger, so my h will be equals to, this is 2 minus 8 is negative 6. I'm going to divide by 2 on both sides, and that's where I will get my h. But this is not the answer. They are asking for the coordinates of b. So therefore, b will be negative 3, 0. Alright, let me close it, make it smaller as we continue to go over to the next part B, where we are going to find the length of AB. This is pretty straightforward, because now that I know the value or the coordinates of B, we could find part B pretty easily. So for part B then, I just need to apply the formula for the length. So formula for length would be given two coordinates, then I will have x2 minus x1 bracket square plus y2 minus y1 bracket square. Okay, so in this case here, then I still have my A, which is 1, negative 8. My B is negative 3, 0. Then from here I would be able to get my x1, y1, x2, y2. So my AB will be equals to the square root of negative 3 minus 1 bracket square plus 0 minus negative 8 bracket square. Okay, and because I do want to, just in case later on for the next few parts I may need this length again, I do want to know what root is this. So I'm going to press my calculator, and this will give me a square root of 80 units. And finally, square root 80 is equals to 8.9443 to 5SF, followed by final answer 8.9423 SF. So part B done. Part C is where we will need to find these coordinates of C, where again there is a piece of important information here. Point C is on the x-axis. This is really important. This information tells me that C, the y coordinate of C, is 0. Okay, and also they tell me another piece of information is that AC equals to AB. So with that piece of information in mind, Step 1, we are going to let C0 be the coordinates of C. And I'm going to just find the AC because I already know AB from part B, right? So my A, which is 1 and -8, and my C is C0. I'm going to just repeat for this AC, and that will be square root of C minus 1 bracket square plus 0 minus -8 bracket square, and this equals to AB. AB is square root 80. Okay, notice Mr. Tan do not use this 3SF answer for this working. Rather, I use the more accurate answer, which is square root 80. And I am going to square both sides so that the next line we do not have any more square root. And I'm going to expand and simplify this. This will give me C square minus 2 times C times 1 plus 1 square. This will give me a value of 64. This is still 80. And continue to simplify. I will have C square minus 2C. 1 square plus 64 is 65. And I'm going to minus 80 on both sides, so that eventually I will get this. So C square minus 2C negative 15 equals to 0. And I would then have to factorize this. And when I factorize this, I will get this answer. 5 and 3, -5, +3. And finally, C minus 5 is equals to 0. Let me create some space, okay? For part C. So C minus 5 equals to 0, or C plus 3 equals to 0. I will get C equals to 5, or C equals to -3. But on this note, it is important to note that -3 here actually represents -3, 0, and this is actually the coordinates of B, meaning coordinates of C would then have to be from here. So C will be 5, 0. Okay? Last question. Now that we have the coordinates of C, last part here would then be to find the gradient of AC. I'm going to just shift the oval, draw a line. And for part D, it's pretty straightforward. Now that I have my point A, which is still 1 and -8, and I also have my point C now, 5, 0, yeah? So gradient of AC is pretty straightforward then. It is just y1, x1, y1, x2, y2. So I just need to have my y2 minus my y1. x2 minus my x1. This will give me a value of 2. And with that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.